That's how it is.
Don't want him to come back? What?
No. Don't be doing that. Yeah. We all know that. I have editing powers. I can just cut that out. So let's see what we have today. Hey, y'all be quiet and listen, or do your work. What we have today, we got a quick little assignment on Discovery Education, multiple choice. I think the reading is still assigned. Y'all just see one assignment or two?
One.
Just one. I'll go in and change the reading right now, actually. Then. So everybody can get to the reading and help you answer some of the questions. Here we go. Text. Change the date to today, which is the 1st of October. Welcome to October. Spooky season? Yeah. It's fall season. I like fall. Okay. So let me go to the reading. And let's take a look at what we have as far as some of the questions. I think most of the questions we probably talked about. I think I've talked about this kind of thoroughly. Let's see. The very first question, though. How do the temperature variations found within the cosmic microwave background radiation, how do they provide evidence for the Big Bang Theory? So let's take a look and see if we can find that cosmic background radiation. Also something, I helped a student out yesterday with the search function. So you can come in here on this web page, and if it's all the reading for just one page, like you see up top, we just have the one page, you can go, well, I got different browsers from you. On Chrome, click the 3 dots and go down and click Find. And you can do a search in that page to find the words that you're looking for. So you can look up microwave background, and you should be able to find the answer for that, or at least where they're talking about it. So let's see. Hubble's observations, microwave background radiation is probably towards the bottom. More evidence. Let's see if we can find this. So they're talking about fusion, origins of the universe. I think they're going to talk about here. Universe following the Big Bang, the initial expansion, 3 minutes of expansion, antimatter is opposite, Big Bang is cooled.
Number 2 is talking about star.
Oh, down here. So I even already have it highlighted. It's down towards the very end, like the last part of the reading that you have to do. So it says, this uniform temperature of the cosmic background radiation indicates that nearly all of the light within the early universe was released at the same time. This evidence supports the Big Bang Theory. That's not exactly what they were talking about. They're talking about temperature variations within the cosmic microwave background radiation. So let's see if they talk about the temperature variations. Nearly uniform throughout the universe with only small variations in temperature. This uniform temperature indicates that nearly all the light within the universe was released at the same time. The evidence supports the... And then the next paragraph right here. The small temperature variations found in the cosmic background radiation represent slight density differences. These density differences represent areas with more and less matter in the universe. The areas with more matter correspond to the same areas that consist of large clusters of galaxies today. This evidence further supports the Big Bang Theory. So basically they're saying the areas with high temperatures correspond to areas that have a lot of galaxies as we look out into the universe. And that helps us confirm the Big Bang Theory using the temperature variations in the cosmic background radiation. They talk about redder. You should know whether red shift or blue shift is moving towards you or away from you at this point. A police car driver drives past you as you stand on the street corner. The siren is higher pitched as it heads towards you and lower pitched as you head away. What causes this phenomenon? There's a particular name for when I was running back and forth across the lab, but don't say it out loud because it's not. You keep your no. You keep your answers to yourself, and everybody can find it.
I love how number 2 talks about a star being in our atmosphere.
Does it say in our
The
atmosphere?
last two.
I don't know. They try to give you some questions or some answers where you're like, I know it's not that one. Objects in space that are moving away from Earth exhibit redshift. Note that it's not the redshift of things moving away from us is not absolute. There are some galaxies that are moving towards us, like Andromeda. Is going to hit us in a couple billion years.
What you said that we'll just pass to each other.
Maybe, we don't know. We don't know. There's a lot of different scenarios. A student argues that if the Big Bang Theory were correct, the first element to appear in the universe would have been uranium. No. The largest naturally occurring uranium atoms would then have decayed over time to produce all. Is the student correct? That student's not correct. We know that the first elements to appear in the universe and the most common elements still today are hydrogen and helium. Yeah. So not uranium. It's okay. Which of the following diagrams illustrates the Doppler effect? You've already had a question on the Doppler effect, and they even talked about a police car, so hopefully they get you. Well, when it's headed towards you, it's going to squeeze the waves together, and so they should be shorter in distance. When it's headed away from you, it's going to elongate the waves, and so it should be stretched out in distance. Hey, do your own work. What are you doing? Are y'all done? No. If you need help, raise your hand and ask you.
Can you help me?
No, not for him. For me. Me. A student states that the universe comprises billions of stars. Student correct? Yeah. I think the rest of these are probably pretty straightforward and we've covered them. So let me double check that. Yep, I think we're pretty good here. So I think I've covered most of it, other than that first question, which I kind of have right here. It should be the pink highlighted part, one of the last paragraphs in the reading. That should help you through that first question. And the rest, hopefully, you can figure out. If not, please send me an email, and I will get back to you and help you out. And I'll post this on Google Classroom. So thanks. Have a nice day.